says attendees still on hold, so looks like you and I
Okay.
might have to hit start broadcast X for them to actually hear it. But it looks like
Okay.
they're popping up.
Yep, yep, 7, so.
Yeah.
Morning. This is Dave Leahy with DASI Solutions. Welcome, everyone. We're giving people a few minutes to log in. We've had a lot of people log in here over the last minute, so we'll be starting here in just a minute. Thanks, everyone. Again, this is Dave Leahy with DASI Solutions. Welcome to a webinar here that we're going to talk about some of the new things that are in 2.16. Looks like most of the people that have signed up are logged in now, so that's great. We can get started here. First thing I have, just a quick question. We're going to start with a poll question to determine, just to get a better idea of how many people are potentially looking at upgrading or have upgraded to 2.16. Just kind of see where you're at with doing this. Great, thanks everyone for, or it looks like the majority of people are going to do it next year. But that gives us a better idea, kind of gives us a better idea. There's a few people that have done it. A few more are doing it before the end of the year. The majority are planning it for next year. So, well, with that, I'll turn it over to Shaun Bentley, our presenter today. I think most of the people, if you've been to training, you've spent some time with Shaun, and he's certainly the expert on this. And I'll turn it over to Shaun and have him.
Sounds good. Yeah, thank Dave, and just pass it on. I'll be able to show my screen there. Share my screen. Should be able to show my main monitor. All right, look good? Can you see that okay?
It looks great.
Okay, excellent. All right, so we've got a short amount of time today, so I'll be very brief on introductions. My name, of course, Shaun Bentley. Been with DASI Solutions for close to 10 years, doing a variety of different things related to SOLIDWORKS, but mostly specializing in the simulation side of our product. So I guess moving into some of the content for this short session, I'd like to go over some of the new stuff in SOLIDWORKS 2016, specifically the stuff related to simulation, of course. Now, some of the items are actually more assembly modeling things. For example, the motion stuff. Maybe you've already seen some of this in some of Darren's presentations. But some of the later things I'll cover on structural and flow are exclusive to simulation, not just assembly modeling per se. So let me go ahead and start off then with talking about our motion product and a few of the new enhancements there. The motion blur, perhaps you've heard of, and also the make controller. So starting off with the motion blur, they've been trying to make the movement of objects look a lot more realistic in 2016. And here from the static image, you can kind of see, you can kind of tell which objects are moving, which ones aren't. Now, to actually show you animations of this through the GoToWebinar tool, it's a little bit choppy. So if you actually wanted to view some of these videos, what I'll do is I'll post links to these in the chat so that you can click on them in the chat and be able to see some of these videos. So this is one that we have posted on YouTube for, it's a billiard table, obviously, and just showing some of the balls moving around. But the example I'd like to show with this motion blur is going to be these couple of links, which I'll go ahead and post right now into the chat. Okay, and they're a different model. Let me go ahead and pull that up. Okay, just something that shows different levels of movement and to show different scales of how the motion blur tool works. Okay, so with this new motion blur tool, if I go into my motion study, let me just play it from start, just so you can see kind of roughly. Again, it probably looks a bit choppy through the animator mode, but you can kind of tell if I just pause it at a moment here. There's no blur to the different components. So you can't tell that this component's moving faster than this one. They all, with the static image, you can't really tell what's going on here. But what I can do is do a static rendering of this blur, or of this motion. If I go into my render tools with my PhotoView 360 add-in turned on, I can actually create a final rendering, and then I can render it with motion blur. So if I go ahead and select that option, it gives me these two parameters, a blur length and a blur offset. Okay, and they do just like what they sound like they do. Okay, so they named them pretty intuitively, but just to be crystal clear, okay, to show you some different renderings of this, go to the length one. Okay, by increasing the blur length, you can see the effect that has. This is just incrementing the blur length up by a factor of 10 each time. So you can see the actual position of the object is right here, but you can see when I increase the blur length, it actually sort of blurs it in both directions. This one's moving the fastest, this one's moving the slowest, so you can see the length is actually related to how quickly the object is moving. So pretty simple blur length tool there. For my animations that I've generated so far, I've basically just been bumping that thing up to the max, and it's been looking pretty good. You may want to leave it at the default. Somewhere between the default and max, I think, looks really good. Then the other option there was for a blur offset, and again, that one does very similarly to the blur length. Well, I should say it's pretty intuitive, like the blur length. By adjusting the offset, you can kind of see here's a centered, and I can offset it to the left, offset it to the right, tell it which way it should put the blur. The default is it puts the blur right at the midpoint. The object is actually positioned here, and it blurs it both ways. But if I offset it to a -16, set that to like -16, okay, it goes from -100 to +100. I found that this seems to be about the sweet spot for getting that blur offset to have the object be actually located here, and the blur offset will be trailing it, okay, because this thing's rotating around clockwise. You'll see it actually trailing it, okay. So hopefully you got a chance to see those two videos that I posted, so you can see the with no blur and with blur, the big difference between the two. So if you have questions regarding that, please don't hesitate to let me know. Okay. So again, two ways you can use the blur tool was this first way I showed you, which was just using the photo view rendering, just clicking on Final Render, and then selecting Include Motion Blur. The second way is if you want to actually produce an animation, that just produces a static image. If you want to produce an actual animation, you have to select Save Animation from your motion tool. And then down here in the bottom, as long as you have photo view turned on, you can turn on motion blur here and then adjust those same exact parameters. Now I've noticed that these parameters here have a little bit different effect than what they do when you're rendering a static image. Okay, when you drag this slider left and right, it's kind of like this slider is a little bit less pronounced. If I set this to 100, it's not as big as me setting the final render to 100 using the static image. So there actually seems to be two different scales that they're using in the background, okay, with this specific model. All right, so those were a couple of the big things I wanted to cover with the motion blur tool. I know maybe, again, you've probably seen a little bit of that already in some of the other What's New presentations, but I wanted to make sure I hit upon that because I think it was important side of things. So next, what I'd like to do, okay, I'd like to talk a little about the mate controller, another new enhancement, more to our SOLIDWORKS assemblies environment, but integrates with SOLIDWORKS Motion. So I'm putting it into the SOLIDWORKS Motion category here. So with the mate controller, you go ahead and shift over to that model. Okay. So this robot arm has a lot of mates inside of it. If I want to try to control the position of the arm, sort of like you can drag and then you can generate animations based on these different positions. But the further away that you get from the fixed point, the more finicky it can get when you're dragging things around. Things can twist around and get all tangled. Now it's kind of hard for me to pull that arm out straight out. So the way a lot of users have been working around this sort of issue is they'd go through and they'd maybe lock specific mates. They'd lock the position of this, then they'd lock the position of that. Then they drag specific bodies around. But now we have this new mate controller that really simplifies that whole process quite a bit. Now I've already inserted a mate controller into the assembly. If you want to insert one brand new, it's just in the insert pull down here. Okay, so if you're wondering how to create one from scratch, just insert mate controller. But once you've inserted one, once you've inserted this feature, if I go back in and edit what I've already done, you can set these different positions. I've already set up a home position, sort of a starting position. Then I've set up a position over the object, and just by adjusting these mates that I've selected, okay, and the type of mates you can select in this list are distance mates, angle mates, basically any mate that has a dimension, a hard dimension on it that you'd be able to change. So distance mates, angle mates, width mates, and also slot mates. Those are the 4 types. So I've set up this position over the object. The object is going to be down here, so to speak. Then I've put it into a pickup position. Okay, so it goes straight over the object, then moves down over top of the object. Then I'm going to close the jaw. So if you watch these, the jaw here very carefully, if I move to the closed jaw position, you'll see it move, right? And then I'll finally lift it. Okay. So the next way I'd like to do is I'd like to move this whole thing over here, swing it all over here, and then drop the object basically somewhere over here. So how do I set up some new positions? It's very easy. I'll just basically select the Add Position button, give it a name, descriptive name. In this case, I'll just keep it quick and simple. Position 6 is fine. And then now I can position these mates just by dragging these sliders around is one method, or they're all, by default, they're all locked. So if I try to drag anything, it doesn't move. I'm trying to move this. So I need to unlock specific mates, and now I can move just those couple of mates, and it doesn't get tangled up too easily since I'm only driving 2 mates at the moment. Okay, so I'll position it up here, and then I'll go ahead and save this position. So I'll just hit like this Update Position button, sort of saves the current position. And then I'll go ahead and define 2 more positions so I can drop the object. So my next position, call it position 7, will entail me actually moving this thing back down a bit, somewhere right about there perhaps. And then I'll lock those 2 mates, and I'll do a forearm twist, so I'll unlock that one so I can twist this guy around a bit, right about there. And then I'll twist the wrist as well. Okay, I want the wrist to be in this sort of a position here and sort of horizontal, okay, something like that. I'll go ahead and save this position, and then my last position will be opening up the jaw to sort of simulate releasing it. So if I go ahead and add one last position, this last one I'll just drag the slider to open the jaw. You can see that it of course controls that jaw mate. Okay. So again, pretty simple to set these up. You just have to have your angle mates and all that already defined, and then you can just control the mates this way. Okay. So now I can go ahead and animate that whole series of steps down here in the bottom. If I select the Calculate Animation button, it'll actually go through and animate all that home position and all those other positions all the way through. Okay. And it does this. You can set times for each one of the steps in here too. Okay. So it's pretty simple. You just go ahead and click and key in how long you want that specific step to take. Okay. Now, what we can do with this is if we want to have a little bit more customizability as far as how it transitions between motions, we can now take this this mate controller and bring it into a motion study. So if I go into motion with this, let's go to my motion tab down here, and then launch the it looks like this camcorder button. I can bring in that mate controller. Okay. I'll delete any existing tracks. I don't think I have any on here anyway, but just in case. And then I'll just go ahead and proceed through some of the steps. We can bring in the mate controls through using animation key points, or actually bring them in as motors. Now, if I bring them in as motors, I need to make sure I set up the mates in this to account for like the inertia of everything and to make sure everything stays connected. I haven't done that with this model, so for now I'll just use it for animation or making 3D renderings. And then finally, I'll just tell it it's going to start with the whole mate controller process at 0 seconds. So I'll hit finish. So now down here in the very bottom, you'll see these keys that it's created. Okay, see a bunch of these keys. And I can adjust the interpolation. By default, it does a linear interpolation. This is something you may already be familiar with. It's nothing new to 2016, but if I go ahead and select all these keys, I can change their interpolation mode to sort of an ease in, ease out. It'll give it a little bit more of a smooth motion as I animate. Okay. So now if I go ahead and I'll also bump up the frame rate as well to maybe like 30 frames per second. A little bit smoother that way. And I can go through the same calculation. It'll look very similar to the way it did before, but maybe a little bit smoother for some of the steps because of that ease in, ease out setting that I adjusted. You can kind of see it slowing down between each step as it does the ease in, ease out. Okay. All right. So again, pretty simple tool. Again, brand new with 2016 to make controller, and you can integrate that with your motion analyses as well to speed up making some of these animations. All right. So now moving back here.
So another quick poll question here before we go into the simulation side. We're looking at, can everybody see this? Shaun, did it show up, or do I have to?
It must be showing up. Looks like we're getting responses, so yeah. I can't see it personally. But
what type of simulation you're using? So we obviously would focus on the right kind of things here that what people are looking for. So looks like 60% of the people are using linear static, and we have some people using motion, which was already covered. A few people using buckling and fatigue, and then a few with nonlinear. So it's kind of looks like a full breadth, but most of the people are linear static as we would expect. So close that.
All right, cool. All right, so I assume you can see my agenda for the structural side now. Okay, very good. All right, so I guess jumping ahead now to the structural stuff I want to cover here. A couple things I'm going to look at are the new blended mesher, curvature-based blended meshing, Unconstrained Bodies tool. In time pending, I'll look at equation-driven results. That's I think a little bit smaller topic than the other three big ones. And then finally, I look at the intermittent fixtures. That's in our nonlinear analysis tool. So I guess to begin with the blended mesher, shift over to that model. All right. So what I'd like to do here is run a very simple study on this particle separator, and really the support frame is what I'm interested in figuring out stresses on, and also displacements of the whole structure. Now I want to try to use solid elements on this perhaps. I can use shell elements to I think a good degree of success on it as well, because a lot of the structure is pretty thin. But I'm going to try to use solid elements and see if I can see how tight of a mesh I can get on this to be able to run it. If I go ahead and create a mesh, you're likely familiar with the standard curvature-based mesh. I think anybody who's using simulation today likely has switched over to the curvature-based mesh by now. They've seen it maybe be a lot more robust. But let me go ahead and try meshing this current geometry with a fine curvature-based mesh. Okay. And in this case, it fails, and likely because the geometry is so thin, it struggles a bit with it. So in this case, the curvature-based mesh didn't seem to work quite as well. It failed on the big particle separating body up at the top. So let me go ahead and try out the brand new mesher that we've introduced, this blended curvature-based. Okay, and with this new mesher, it gives me this extra little control here to calculate a minimum element size. Okay, if I go ahead and select this, and then I can have it figure out what the minimum radius of curvature is and calculate. It'll come up with, in this case, about 3 millimeters. And if I go ahead and select apply, it applies that as the minimum element size. Okay. And now if I go ahead and accept, if I go ahead and click OK there, we'll see if this blended mesher does a little bit better job. Okay. So this time, it gives me a warning about high aspect ratio elements. I'll go ahead and hit yes to this warning so it'll show me aspect ratios. Okay. And it looks like it completed the mesh, but with a warning saying that we have these aspect ratios that are on the order of like 5,000. Now, to describe these aspect ratios to you and why this curvature-based mesh starts focusing on them, let me bring up a slide here. So elements that are usually more efficient are ones that have an aspect ratio close to 1, kind of like this equilateral triangular element that we have here. Aspect ratios much greater than 1 are usually a lot less efficient. And the way we calculate the aspect ratio is typically something along the lines of longest leg length divided by the shortest leg length. So here, the aspect ratio might be like 20 or 30 or something like that if we do the division. Okay. So, and if we compare some of the different measures, if I take a look at our standard measure, the very first one on the list, here's sort of the way the aspect ratios look. And the darker colors mean better aspect ratios. So the black elements you see are ones that look like equilateral triangles almost, you know. And the ones that are white or red are the ones that are brighter colors. You can see they're kind of deformed or twisted or tight. Okay, they don't look like equilateral triangles. So this is a very, very simple model here. I've just drawn a circular surface and punched a tiny hole in it, put a mesh control on it, so we can see how the standard measure does at giving us good aspect ratios. And we do see it. The aspect ratios aren't huge, but you know they are kind of. You know, we want to try to keep them under 40 in many circumstances. They don't quite get up to that level, but if we compare the standard mesh to the curvature-based mesh, it's hard to say exactly which one's doing better. With the standard mesh, we have a lot of white, a lot of things that are above 2.5. With the curvature-based mesh, a lot of different colors. Okay, it's almost interesting to see sort of a fractal kind of appearance to it, how it's filling the face. But then there's a night and day difference, though. If I move on to the new measure, here's the new measure. Okay, so you see a lot of black elements, meaning that the aspect ratios are very good compared to, and if I go back and forth again, sort of a night and day difference between our curvature-based and our new blended measure. Okay, now this difference is at the surface level only. Now, if I do this same comparison, well, first let me just wrap up that comparison, I guess. At the surface level, you see the blended mesh does a lot better. We have a lot lower aspect ratios, a lot higher frequency of lower aspect ratio elements. And apparently the curvature-based mesh seemed to be maybe a little worse, actually. Perhaps. It's hard to say conclusively, but it looked like it might have been a little worse than the standard mesh. They're comparable. Now, looking internally, though, if we look at volumetric, okay, this difference seems to be on the surface only. If we look volumetrically, I'm using the new mesh sectioning tool to be able to see inside here and see the mesh inside of the cylindrical body. Here's the standard mesh, here's the curvature-based mesh, and here's the blended one. They all look pretty similar, okay, very noisy sort of information. And if I do that same kind of graphical comparison here of the volume aspect ratios, the blended is on par with the other two. It's a little bit better because on the surface it's doing a lot better. But internally, there's still some work to be done. Okay, but it does seem to be a little bit more robust, at least on some models. So I would recommend that if you are having a hard time meshing your models, switch over to the blended one, see if that'll work, and it should give you better aspect ratios on the surface. Okay, so continuing then with this example, what I like to do then is maybe we can reduce the aspect ratios. This aspect ratio we're seeing is around 5,000. Okay, which can compromise the accuracy of my results to some extent and also make it a little bit more inefficient to run this. So if I go ahead and just cut this mesh size in half perhaps, and I'll use that same calculated size, I might see a lot better aspect ratios this time around. Okay, so I'll go ahead and generate the same aspect ratio plot. And I'll have it go from 1 up to whatever automatic maximum it finds, which in this case is 129. So a lot better with this smaller aspect. Still pretty big aspect ratios, but a lot better than the 5,000 we said before. And if I do some mesh sectioning, this is another new tool in 2016, you can see why these aspect ratios are so big. Okay, if I go ahead and let me just drag this section upward a bit, closer to where that maximum is. Okay, if I look down at some of these elements, okay, you can kind of see how thin they are. You know, see why their aspect ratio is so large, just because of how thin the geometry is. Okay, so the mesh sectioning tool allows you to really dig down pretty deep and see what your elements look like through the geometry. Okay. So now what I like to do is maybe I'd like to try to run this this study with the current mesh. Okay. So if I go ahead and attempt to run it, there's been some enhancements to some of the error message reporting in SOLIDWORKS Simulation. So I'd like to see if I get any errors. I'm not sure if I have everything bonded together quite yet, and a lot of times I'll just run it and just use that, just clicking the run button as a troubleshooting tool. I'm sure a lot of you also do that and just see if you get an error. And if you do get an error, then you sort of go into troubleshooting mode at that point. So this one takes, I think, a little bit over 30 seconds, and then I get an error that says array of solver stopped, and it tells me to search a knowledge base and gives me an actual direct link. If I go there, it actually brings up a knowledge base article for me that's relevant to this specific error, and even has a PDF file that I can, let me open it up, and I can get much more details into what that error message meaning is. Down here, it gives me some suggestions for troubleshooting methods and tells me about another new tool in 2016, check for unconstrained bodies. Okay, so in order to check for unconstrained bodies, that's a tool that's available right inside of our connections folder. Just have to click OK to get out of that error. If I go into my connections folder, this unconstrained bodies tool allows me to run a smaller calculation to determine what bodies are unconstrained and what their degrees of freedom might be, if they're able to move around in the X, Y, Z directions, and so on. Okay. So it looks like it found a body. If I select the body, this body, it says it's unconstrained. It has translation. It has a translation available in the X direction, in the Y direction, and in the Z direction. It looks like it didn't get bonded to the surrounding beams. Okay. So in order to fix this issue, let me just inspect that region more carefully. I thought I had a global contact with everything set to bonded. Oh, but there, of course, is there's a gap there, so it won't bond that together by default. I need to close that gap. So at this point, I would go ahead and adjust that mate, key in 0 for its dimension, maybe just make it coincident there, and I'd be able to go ahead and run the study. But I'd like to move on to some other topics here. Again, time is short. Okay, so I just want to show you those couple of tools. If you would like to see the run on this, just let me know later on in the session, or maybe stick around after the session. But wanted to show a couple of those quick tools. So moving back then, we had another poll question, I think, for flow. See if we can. Are you launching that, Dave? Okay, looks like Dave's launching that. Just want to see where everybody stood as far as flow. See how deep I might need to go with some of the features. Looks like for the most part, flow is pretty new. Most people answered with the first response. Flow is pretty new to a lot of people. A couple of people have been through the 2-day training as well, so it seems to be the bulk seems to be new. Okay, I think that's might be close to everybody. Go ahead and close that. All right, so some of the new flow features that I'd like to show are going to be the new meshing interface and some of the tools associated with that. I want to show the faster transient solver, and also want to show some of the time step controls available as well. And then we'll move into some of the new result tools that are available and show some of the filling gaps options as well. Okay. Time pending, I might go back to some of the other topics as well, but we'll see how we do. So new meshing interface and tools. Let's start there with another model. All right, so I have drawn this sort of teardrop shape. It's sort of a streamlined shape. I want to calculate the drag coefficient on it. I want to take a look at the drag forces, figure out the drag coefficient. So I'm going to show you, I'll walk through basically a study from scratch so I can illustrate some of the new tools that you're going to see when you go through some studies in Flow 2016. So if I jump into a new study from scratch, just jump right into the wizard. Many of you are maybe already familiar with Flow being this wizard-based setup tool. If I jump into the wizard, I'll next through the project name. I'll use some of my own customized units that I've created. I'll do this as an external study since I'm going to have the solids surrounded by fluids. And I'm also going to make this a time-dependent problem so I can calculate some of the turbulence that might be going on behind this thing. Okay, and I'll run it just for 5 physical seconds. Okay, and looks good there. For my fluid in this case, I'm going to have this thing moving through water. Okay, it's underwater. Then for the remainder of these steps, I'm going to accept a few defaults here. I'm going to make the velocity 5 meters per second. So I'm going to pull up a reference I'm using for these as well. Stream there. Okay, but I'm going to use 5 meters per second in the X direction. And now notice here, normally I'd have a next step. So here's one difference. Normally I'd be able to hit next. Right now it says finish. Normally my last step here for a lot of you who've used Flow for some time is to set a result resolution level. But you see, after I hit finish, it didn't give me that option to set the result resolution and the mesh size and all that. Now we've just placed it as part of your input data. Okay, now the mesher is here. And in order to adjust the mesh, we can do it at a global level, or we can insert local mesh controls, kind of like the way structural analysis does it. So it's a little bit more consistent with our structural analysis tools now. And if I added the global mesh, you can see the slider here. It's a little different. Instead of it going from 1 to 8, now it goes from 1 to 7. And let me turn on the basic mesh so you can see what this is doing in the background. If I go from 1, 2, 3, 4, 5, and so on. And it's kind of like developers try to make it to where if I adjust it by one level, it will roughly double the amount of cells. Okay, it should roughly double the amount of cells each level you go up. Okay. Now I want to turn on uniform mesh here as well. Okay, you see without it, you can kind of see the elements closer to the object or a little finer, which is good in many scenarios. But in this scenario, I'm going to do uniform. And also, I want to display refinement level. This is also another new option, and this is just this just allows you to see, just to display if you're to do different refinements. Here's a level 0 refinement, level 1, level 2. We can look at this region and ask ourselves, what sort of refinement might I need here in order to really capture this curvature? Will a level 1 refinement do? Maybe a level 2? You can kind of experiment these different levels to see what might be good for that region. And usually, you might use this for tiny features or small inlets, okay, if you wanted to see how refined you need to go in order to capture those. Now, to review these refinement levels briefly, okay, so here it shows level 0 refinement, level 1, level 2, level 3. It's another new tool inside of Flow 2016 is being able to display these refinement levels in these sort of graphics. We have a bunch of different new parameters that they've added to be able to display these curvature and refinement levels. So what I like to do is set up this sort of a refinement scheme, though, where I have level 1 cells all back here to try to capture the wake that's going on behind here. Then also I'd like to set up some equidistant refinement in this region, okay, so that I have level 3 cells for about 20 millimeters worth here, and then level 2 cells for about 60 millimeters, okay. So I'll use some of the new tools in order to accomplish that. Okay. Now also this model is symmetric, so I want to take account to symmetry. So I will go ahead and do that. Okay, I'll turn on symmetry in the Y direction here so you can kind of see it's just going to run the calculation on this side of the model. And also I'll use sort of a 2D planar study here by setting up periodicity in Z direction. Okay, so you can kind of see the region I'm really calculating on is much smaller now. Okay, that's nothing new there per se, but being able to mirror the results later I'll show is brand new. So let me go ahead and make a couple other quick adjustments. This is just going to be level 1 uniform, like I was saying. And also, I'm going to switch over to a manual mesh so I can key in a mesh size here. This is new where I can select this button and key in. I want the mesh size to be 30 millimeters rather than a cell count. You can set a cell size in both the X and Y direction. And I only want one cell in the Z direction. Okay. Rest of this I'll leave as default, nothing else too new down here. They did enhance the control planes interface as well. That's something you can play around with on your own there a little bit. Let's try to keep it quick and simple here. So some other new things in here are if I want to adjust that local mesh, I want to make the mesh finer near the face, I'll insert a local mesh, and I'll select that face, and it's this equidistant refinement option. It allows me to accomplish what I showed in that slide earlier. I'm going to set 2 levels where I'm going to say up to level 3 here. And I'm going to set this at 20 millimeters and 60 millimeters. And to describe a little bit about what's going to happen now, I'm going to have level 3 cells at this first layer up to this, right around this 20 millimeter point here. Okay, this is a 20 millimeter offset away from that surface that I'm highlighting here. So it's going to be level 3 cells all the way up to that. And then I'm setting at 60 millimeters, which is this guy. There's going to be level 2 cells. From here to here, there's going to be level 2 cells. Then it'll move down to level 1 or 0 once it gets out here. Okay, so that's brand new, equidistant refinement tool. Okay, pretty simple to set up. And then also another brand new feature is if I insert another local initial mesh, I have an option for setting regions. Okay, you used to have to actually model these regions. You used to actually have to draw a rectangular prism and then disable it. Now you can just actually drag these things around to make your rectangular prism. Okay, and I want to refine this somewhere right in this vicinity here. So I want there to be at least level 1 cells in this whole region here. Okay, so I'll just bump this up to level 1. Okay, that's also, you can do cuboids like what this is, cylindrical regions or spherical regions to specify these refinements as well. Okay, so those are a couple of the big enhancements to the meshing side of things. A little bit more, quite a bit more control there. Now I'll go ahead and set a few other parameters here. For example, if I go into my calculation control options, okay, I'm going to set the adaptive refinement. So this is nothing new. Something that is new about this, though, is that the mesher does not automatically turn on adaptive refinement anymore. You must manually turn it on. Okay, so it kind of simplifies things a little bit. Okay, some users got confused when the adaptive refinement would automatically be on because they'd set the mesh to a level 6 or 7. But now it's just we have to go in here and manually enable adaptive meshing. Okay, and I'll just set a couple of the controls here. Again, nothing too new about this. Okay, but I will set an adaptive refinement to happen at 2 physical seconds. And then now, what's new under the solving tab though is we can do nested iterations. Okay, and this is a huge benefit. This is a big enhancement. This is for transient analysis only. Okay. It's under the time step settings. It's for transient analyses only. If you're running steady state, you're not going to see this option. But what this basically does is it makes your transient studies run a lot faster, maybe twice as fast, maybe 8 times as fast in some scenarios. Okay, so this is a huge benefit to anybody running transient analyses. Also, I'm going to set a time step. I'm going to manually set time steps. And also another new thing that they're doing, and if you want to set these time steps, let me just demonstrate by setting a couple of parameters here. Okay, so I'll have this go from 0 to 0.001. You'll kind of see what this is doing in a moment once I go ahead and specify this table. You can also copy and paste from Excel if you want to copy and paste these steps in here as well. Okay, 0.25. Let me show the chart. Okay, and I'm going to set up these logistic joints. Okay, so what I've basically done here is I'm saying to flow simulation, start off slow. Start with tiny steps, take baby steps, and then slowly make the steps bigger and bigger and bigger. Okay, and then I'm saying at 2 physical seconds, which is when the refinement happens, start out slow again, take baby steps again, and then go bigger and bigger and bigger, and then start moving quickly. Okay, so it's a way they've given you this control, so you can really control how, when to slow down the analysis to try to help with convergence. Okay, if you're bumping into some convergence issues. Okay, so I'll go and accept that. And also I'm going to bump the number of nested iterations down to 10 instead of 25. And that's good there. Okay. Now to discuss this nested iteration idea a little bit more, just to show you how much faster it can be. I ran a bunch of different scenarios with and without nested iterations. Without nested iterations, you can see how much longer it takes to get the same level of accuracy, like the same 1% error, for example. It takes this is a logarithmic scale here. It takes looks like 4 times longer, maybe closer to 8 times longer in some scenarios to get the same kind of result. Okay, so you can see how much faster the nested iterations is than the old way. Okay, now and if you set the different iterations, you can set it 25, 10, 50, a bunch of different. You can even speed things up further, but it's not always guaranteed to be faster. I set 10 iterations now. Well, if I'm going for certain lower level or certain higher levels of accuracy or lower levels of error, it's actually faster for me to just leave it at the default. Okay, So you can kind of experiment a bit with this. Maybe for the most part, you might just leave it at the default 25 nested iterations that was set there. Okay, and now this was done on a specific validation example, so your mileage may vary. Okay, the specific validation example I was using was a heat transfer one. Okay, and you might see a bigger benefit from heat transfer problems than you might see from the problem I'm simulating currently. Okay, so if I go ahead and run the analysis that I've just set up, here's sort of what the run looks like. It's just sort of a time-lapse recording of it. You see briefly what that looks like. Okay, so you can kind of see the time down here. It hit 0.1 seconds, hits 0.2 seconds, and you see it speeding up, 0.3, 0.4, 0.5. It's going really quick. Then it slows down at 2, and then speeds up again. Okay, so you see that's sort of a direct impact of those time steps I set. Down here, I'm showing the nested iterations. It doesn't have to run the 10 nested iterations. It's only doing 2 or 3. Sometimes it'll do 10. When the residuals are large, okay, these residuals are kind of like error. You know, these are these residuals. If these things grow too big, then it'll be forced to do 10, the full 10 iterations. Okay, so you can kind of see a little bit of behavior there. I know you won't have a full understanding of all the little details, of course, but I just want to give you a little preview of that. Okay, so again, nested iterations, faster and more accurate than the old way without them, at least for heat transfer problems at the very least. Okay, so next what I'd like to do, I want to look at that gap example as well, then wrap up. So let me jump to my gap model here. Okay, so there's a tool within Flow that allows you to close gaps. Okay, brand new tool in Flow allows you to close gaps. It's right inside of the global mesh settings now, this global mesh tool. If I edit it, there's this, they call it the closed thin slots, actually. Okay, and you see what I've set this to. I've set it to 15 millimeters. And you see I have this gap here that ranges between 10 to 20 millimeters. So 15 millimeters actually corresponds with this point here, roughly. Okay, so it should close, theoretically, it should close this region off right over here on this side of the model and leave this region open. Okay, and if I go ahead and mesh and run this thing, which I've already done, you can see what the results look like. You can see that the region that gets closed off. I put a heat transfer on this so you can kind of see the temperature across here, and you can see kind of how it closes that region. Looks very interesting. Okay, you can see these cells, the ones that are closed are the ones that are colored in. Okay, so it's treating that region as solid. So notice, interestingly, it didn't close the very edge here, though. Okay, so it only seems to be closing the cells that are sort of completely within the gap region. Okay, so it allows for heat transfer across that region, which may or may not be desirable. You may want to check your model if you ever use this gap option. It's closed thin walls or closed thin slots option, or whatever we called it there. Let me remind myself, closed thin slots. You may want to just double check, make sure you're not closing things unintentionally. But very handy for sort of ruling out some of these regions. Rather than doing fluid dynamic calculations in there, which can take a lot longer, it's just going to close it off for you and make it a lot more efficient to run. Because a lot of models might have these little tiny sliver gaps in them that you want to close off. So you might key in a much smaller size for this for more practical examples, something maybe on the order of 0.1 millimeter to close off any really thin regions. Now, what this tool is not used for, surprisingly, it's not. You do not use this if you want to run an internal study and you have leaks. This does not close leaks. So I'm sort of differentiating a bit between a gap and a leak here. Okay, this will not close leaks. Okay, maybe in the near future it might be able to. Okay, I can definitely see some enhancement ability for this, but currently it does not. Okay. All right, so I guess we're pushing close to the end time here. I wanted to leave some time for questions, but there was one other model that I promised here, and let me cover it briefly, going back to our structural.
If you've got some questions, please type them in while Shaun's going through this. So
yes,
we can
very good.
Be ready for
yeah, very good. That's a very good idea. All right, so yeah, so if we please go ahead and start typing in questions, and then what I like to do is walk through this last structural example, one I wasn't sure I was going to have time for, and maybe I'm kind of pushing it, but there's this new intermittent fixtures tool that's available with our structural analysis tools. I know it's a little bit out of order here, but to show this briefly, and maybe there actually is already YouTube videos that do show this exact example, so you can actually watch those as well. But to show this briefly here and add my brief comments to it, it's sort of like on this example, I want to push this clip closed, and you can kind of see it snap into place. I just go ahead and play the animation. If I push it closed, it'll sort of snap into place. And then I want to release it. I want to be able to release it, pull it back out, all in the same study. Now, the way that I used to have to do it would be I'd have to run it as two separate studies, or I'd have to apply a force here that I'm turning on and off. But forces tend to be a lot less stable than applying it as fixtures. Okay, with these fixtures, you can apply displacements, and they converge a lot more easily than applying just loose forces. So in this case, though, if I have a fixture on this point to sort of simulate my finger pushing up on this, if I have a fixture on this the whole time, it's going to hold this thing down, and it's not going to allow this thing to move upward. Okay, which is why I need to be able to turn on and off that fixture. If I go and edit this curve, this is sort of where my finger is pushing up and down. Okay, if I view it, it's sort of like my finger is not on it for the first 0.6 seconds, let's call it, the first 60% of the animation that you saw there. My finger isn't even touching it. And then my finger starts touching it right at the 60% marker, and then I start pushing up on it, and I hold it for a moment, just long enough for it to come back a little bit, and then for it to engage with this. Then I release it. I take my finger back off of it, which is why you see the red line goes away completely. So this ability to turn on and off fixtures is brand new to 2016. And that's just what I wanted to show briefly there. And it's very simple to set. You just have this little drop down as you're going to adjust these curves. You just have a little drop down and turn them off. Okay. So pretty simple idea. Very handy for nonlinear. Very handy for trying to make sure you get stable converging results in our nonlinear analysis tool. So let me just go and animate that one more time. So it moves closed, then my finger engages, pushes up, and I release and let it go. Okay, let it continue to pull back, of course. All right. So very interesting there. All right. So moving over to any questions. Did we get any at this point?
I have not seen any questions.
Okay, looks like, yeah, no questions at this point, so maybe, I suppose that was enough time to generate some. Maybe we'll wrap up, and let me show, if you do think of a question later, you might want to copy down. Maybe you already have my email address. Many of you who have been through training likely already have my email address or business card, or know how to get in touch with me. But also, if you have any questions related to sales, Dave Leahy's email also listed here as well. So
great, and we're going to make this available as a recorded webinar, so you'll be able to find links to this on the DASI website, and we'll try to also send a link out to you all so you can look at it if you need to focus on something when you're actually trying to use some of these tools. You may want to look at this again.
All right, very good.
Don't have any questions. We appreciate you spending some time with us today. Hopefully this was informative, and thanks for joining us.
Yeah, thanks for coming. Take care.